Hi everyone there. This video was actually talking about the Robert's law. This law is something that I haven't come across till now, and this is something which is present only for Osmania University students. And in this syllabus, we have something called the Robert's law. So the law is very simple. It states that any coupler curve it can be traced by three different four-bar mechanisms. So a coupler curve is the path traveled by a point on the coupler, which may not exactly be on the straight line between the joints, but it may be displaced from them. And you can see this link ABC is one of the couplers, and the path traveled by this point C is the coupler curve. So in this particular case, what has been done is we have taken an equilateral triangle, and from the midpoint of these two links we have got this upper coupler, and the bottom links, they have become one of them has become the crank, and the other actually we will get rockers in both the mechanisms, because this 4-bar mechanism doesn't satisfy the Grashoff's law, and hence comes under the type 2 4-bar linkage. So the point here is that this coupler curve that we are getting here in the shape of an equilateral triangle, this coupler curve can be traced by three of the different 4-bar mechanisms. So I just wanted to prove this using OnShape, and here is what I had got. So here you can see I have placed the same coupler curve. In fact, you can just take it to the same position like this here. So this position here you can see here in this mechanism. I'll just disable the dark mode in case you don't like it. So here you can see that same mechanism. Let me take the dimensions between these two links, and I'll set it as 60 degrees. So you can see this particular mechanism, it's exactly mating the equilateral triangle. All the sides of this triangle are 100 mm. You can see this is 50, and this particular point is the midpoint of this line, and hence we are getting an equilateral triangle. We have taken the midpoints of these two, and we have formed the upper triangle, which has become the coupler, and these two links are the other two links of the 4-bar mechanism. So I'll just delete this dimension so that we can start moving it, and when we move it, this is where something unique starts happening. So at this point over here, it travels almost on this straight line, and if you see the structure of this mechanism, it's a Roberts straight line mechanism, which comes under an approximate straight line mechanism. So as you can see, if I zoom in and try to see if this point exactly travels on the straight line, we see that no, this point actually doesn't travel on a straight line, and rightly so. Roberts mechanism is not an exactly straight line mechanism, and hence this is usual for us to see. So as we move it, you can see this point on the coupler, it travels approximately on this path that I have drawn. So I can continue to move it for the whole of this block. So we started from some position over here, and we were able to come back onto that, and this point always try to trace this path that we can see in the form of equilateral triangle. So the same path, according to Robert's law, can be traced by three of the unique 4-bar mechanisms. So that's what we shall see in this video. So let us take the same mechanism, but this time instead of taking the bottom 2 points as the points which are as the frame for the 4-bar mechanism, we will take up these 2 points. Fine. So these 2 points we will take up as the fixed points, and again we'll form this particular mechanism. Okay, this particular mechanism, and again we will get the coupler path. So this part on the coupler, it will always travel on the straight line. So you can see as I'm moving this, that point here always tries to follow the same path. Right. So it's moving on the path. Let's move ahead, and at the end of this, again I'll have to come onto this side actually, and let's continue this over here. So you can see this point is actually trying to follow that same straight line as far as possible. Fine. So we have taken these 2 points as fixed points, and we have taken these 2 points as fixed points. Now let us take up these 2 points and fix them and make this 4-bar mechanism and try to see what kind of the path is traced by this. So I have taken these 2 points as fixed, and again we shall see that this robots mechanism as well tries to follow this straight path. So the path, the coupler curve, is actually a triangular in shape, approximately triangular in shape, and we can see that there are actually 3 unique 4-bar mechanisms that are able to trace that approximate straight line path, the same coupler curve. Fine. Now after going through these, I was a little more skeptical about the Robert's law being true, whether it actually follows truly or not, and I just wanted to see if all of these simultaneously, if they were put, and if the point of these points, the coupler points of all the 3 mechanisms, if they were actually coincidented, then would they be able to move correctly or not. So with that aim, I was able to form this particular mechanism. Of course, it's very difficult to understand how the mechanisms are there, but you can see that all of these bottom 3 mechanisms have been overlapped onto this. So this over here, this is the coupler for the first one, and this you can see is the coupler, actually this here, yeah, this, the coupler that I highlighted, that is the coupler for the bottom 2 points, and yeah, the other coupler over here, it's going to be very difficult to select actually. Yes, this coupler, it's actually found by these 2 points. Fine. So the 3 triangles are there here and have coincidented this point over here. Fine. So this point has been coincidented, and all the lengths are of the same, the 50 length. So when I try to move it, it's actually able to move. Fine. And the result looks so great. Fine. Fine. So great the result looks. And actually, if Robert's law had not been true, this particular diagram should have turned red as soon as I had coincided the coupler points of all the mechanisms. But because that has not happened, and it's conveniently able to move, all 3 mechanisms overlapped with each other, that means the Robert's law is actually indeed true for almost all the combinations. Thank you for watching this video, and if you get across any of the better examples, you can always let me know, and I'll be making the videos on them as well. Thank you.